Okay, so now we move to the more to 6. Yeah, this one is everything about array. So now let me review about the last class. We learned everything about the loop, right? So in Zask, it's one of the most common application when you work with the loop is when you find out what the sum and what is the average, right? So think about is you have a program here. You have the program, you have to find out what the average grade of all students in the class. So you have the program to ask user how many students, right? For each of the student, you have to enter the grade for each of one, right? And it's sum it up together. And at the end of the program, you find out what's the average here. It's very simple, right? You have to maintain the accumulator for each student. You just sum it up together. So when you have the sum, you just divide for the how many students, and then you have the average here, right? Now, if you look on this program on the left, it is Raptor. On the right, it is a it's a Python here. So let me ask you a question here. Let me think about if I enter for 10 students, I enter 10 students, and I find out what's the average or what is the sum here. Now, what happens if I want to go to check again what is score? Sorry, what is the grade of the second student, or what is the grade of the third student? Can I do it or not? Can I do it or not? Or is it? Why? Why you cannot do that?
Because it gets reset every time.
Sorry?
The score gets reset after each one.
Yes. The thing is that you see, if you look on this program, right? You maintain only one single variable. Right? You see, you maintain only one single variable. For this one, it's a grade here, and for this one, a grade here. So what happened here? If the first student he enters a 70, you store it in the grade here. But if the second one he enters the 80, it overrides the 70 here, right? So basically for this one here, for this program, this type of program, you only maintain one single variable. That's why whenever you have the new value for the new one, it will override the old one here, right? So basically for this one, I have no way to go back to see what is the grade of the first one, of the first student, of the second student, and so on here, right? So that is the problem is this one here. With it, when we work the loop here, the grade of the previous student will be overwritten here. So how we will overcome this one? Overcome is this one, right? So we can think about you can generate from multiple variables here, right? You generate grade number 1 for the first student, grade number 2 for the second one, a grade number 3 for the third one. But for this one, you have to manually enter them, right? You cannot do the loop anymore. Make sense? You cannot do the loop anymore. And you see what happened if you have the 100 or 1,000 students. You have to do it manually, and you have to maintain a lot of the separate variables here, right? Okay, now you can overcome all of the first problem and the second problem by using the array here. So what is the array? In this chapter, we learn about what are the array, how to create and load data in the array, and some of the application, sum and average is the same with the loop here. Find the minimum and maximum number. How can arrays replace the net decision, searching array for exact match, using parallel array, and so on here. Now, what is array? Array is a series or the list of variable items stored in the continuous memory location. Remember that? I don't know, contiguous or continuous, I think it's the same. But you can think about this one here. You have the memory in the RAM, right? So basically you have the slot of, in the RAM here, you have the slot of memory in the RAM. So you can think about this one. You break it down into bytes. Think about it, very simple here, right? You break it down by, so byte number 0, byte number 1, byte number 2, and byte number 3, and so on here, right? So we think about if you want to store, now it's very simple here. If you want to store an integer number, right? You want to store about integer number. So basically, for integer number, you need the 2 bytes. It's to make it simple, right? So for this one here, you can see you can store number 8 here, and you store the number 6 here, and they store it continuously in the memory location. That's the first thing, right? They store it continuously. So we see, and that's the first thing. Now the second thing, what is it? All variables share the same name. You see, for this one here, they have the same name. Name here grade, name here is grade, name here is grade, name here is grade, and name here is grade. The only difference between them is the index number here, or sometimes they call it the subscript here. Right? So see, they all variable here, they share the same name and must be the same data type. So basically, when you work the array, all of them, if you store the number, integer number, you have to store all of them in the integer format. Basically, for every other program language, but in the Python, it's not applicable in the list in the Python. So basically, in the Python, they have no exact definition of array. Instead, they work with a list. The list work quite similar with array, but it's very flexible. In the case of the list, you can store a variable into multiple, in the different type here. It's not always the same. I'll show you later with the list here. But anyway, for this definition, you have to think about it's applicable for most of the programming language. You have the same name and must be on the same data type. Now, the second one, and the third one here, each variable has the different subscript here. You see, number 0, number 1, number 2, number 3, and number 4, or sometimes they call it the index. So it depends, right? Sometimes I call it the index or subscript, but anyways, they work the same here. Now you can think about this one here, right? You have for this array here. For this array, you have the name of the array. It is a grade here, right? And you have 1, 2, 3, 4, 5. You have the 5 element. You have the 5 element in the array. Number 1, number 4, and number 3 here. And remember one thing is very important here. If you work the array, the subscript here always starting from 0, not from 1. Remember that. So basically, for all of the programming language, when you work with a subscript or when you work with index, it always starting from 0. But another important thing you have to remember, you have to keep in mind here. If you work with Raptor, it's starting from number 1. That is a huge difference between the Raptor and the real programming language. That's why I want to keep you in mind when you work with the real programming language and when you work with Raptor. So remember, if you work with Raptor, the first index is number 1, not number 0. Okay, element is an item in the array. Subscript is the position number of item in the array. It's always starting from 0 to all over to the one less than the number of element in the array. So we think about this one, you have the 5 element, right? And that's why the subscript starting from 0 and come over to number 5 minus 1 is number 4. Make sense? Okay. And the size of the array is the number of elements in whole. For this one, you have the 5 element here. And each array element can be used in the same way as a single item of the same data type. For example, if you want to access its grade number 0, you got is a 70 here, right? And if you want to take it out, what is the grade of the first student? What is it? So what do you think? Grade 3 here. What is it? If you look on this one, what is it? Grade number 3 here. What is it? What's the value here? 90. No, not 65.
Oh.
Yeah. The grade number 3 here, that means subgrade number 3, actually it is a student number 4. That is huge difference. You have to remember it here, right? So 0, that is 70. Grade number 3, you have 90. Make sense? Okay, so how arrays occupy the computer memory actually is that stored continuously in the memory here. Now, how you create and load data in the array? So, now, in order to create the array, there's just placing the element inside the bracket separately by the comma here. I still think about for this one, if you create the my list here, that you have no element here. Or they call it the empty list or empty array. Right? You see, for this one, you have array or you have the list with the 3 element 1, 2, 3. And this one in the Python, you can do this one. You can generate a list with the 10 element, and all of them is the value 0 in the Python only. That in the Python only. Right? So basically, you can do it here in the Python. So I can show it in the Python here. Okay, so see, it generated for the 10 items, all of them 0 here, right? Or you can change it here, whatever you want, right? You can change it here. You can change it to the number right here. So in that case, you have, sorry, you have to put first, and this minus here. Okay, or in the list also, right? You have the list here. Very important in the case of the Python, you can store it into the multiple variable here. So we have the A, we have hello, sorry. Hello, or you can have the 6, 8, 9 here. Oh, mistake. And I can print my list. So that is very special about the Python. The Python is a list, they can store the data in different types, not on the same type. But anyway, in other programming language, they work the C or C++ or Java, they must be on the same type in the character array. But the list in the Python, they are flexible. This one, you see, this one the character, right? This one's string, and this one's number. Right? Okay, so to create an array, you can put this one with empty array, right? This one with a 3 element, or in the Python, you can do it here. Now, how you load data in the array? How you load the data array? So we think about the first important thing you have to remember that if you want to load data in the array using the loop, that's all. Because you see, they work continuously, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You just generate the loop, it's starting from 0, and for each iteration of the loop, you just increase the counter by 1. Right? Now think about this one here. If you want to load the data in the array with definite number of elements, you use the for loop. Right? Remember that in the Python, you work with definite number of elements, you work the for loop here. Now think about this one. Think about this program here, in my program here, right? In my program here. Now see, this one, it is a definite number of iteration because it depends on how many numbers. It depends on how many students you have, right? That's why you have how many students here. I starting from the number 1, right? So see, I starting from number 1. I have the condition here. If the count is greater than number of students, I exit the loop. If not, I keep enter. I keep enter the name of student, right? And we store here. Now see, the huge difference here is that if you look on the program here, now I store it into the array, not the variable anymore, right? So see, that is the name of array, and the count here it is a subscript. Right? So see, but remember one thing: when you work with the router, you have starting from number 1. But in other programming language, it's starting from number 0. You see, it works exactly the same, right? That is the prime input. You have to initialize the counter who controls the loop, right? Check the condition here, and for each iteration of the loop, you have the action to change the variable who controls the loop. 3 loop, right? And the only difference here, you store it into the element of the array, not in the single variable. Right? So see what happened with this program here. I think about to make it simple, I run it 3 times here, or 3 still here, right? So we see I have the 3 here. Now the first one, name of the array, I have the 17 B. Sorry. Oh, this one, sorry, name of me. So I run it again, 3 still, right? I have B. C, now I exit it. I know for sure it exit. I do for 3 times. You can see in the loop here. In the array here, I have name that index number 1, A, index number 2, B, and index number 3, C. Right? So now see, when I store it separately into every element in the array, for sure I can go back to see what is the name of the first student, or what's the name of the second one, and what's the name of the third one. I think about this one here. If I want to see what is the name of the first student, I can go back here. I can just print it out. Print it out. This one, name number 1. So see, I done it again. have A, B, C, and C. The end of the process here, I'm still able to go back to see what is the name of the first string. Make sense? That's a huge difference between the variable and the array here. Array is stored separately into multiple slots of memory. That's why you can go back to processing later if you want. Right? Okay. So that is the case of the router, right? So in the case of the for loop here, if you work with a definite number, in the case of the for loop, you work with the range, right? You see, number in how many number in the class, right? Oh, I don't know. Okay, this one, okay. Basically for this one, you have the multiple way to exact with this one here. So I can explain it to you later. So think about this one here. You have the number. You have to enter the number array. Right? Now think about you have the array here. So process here. Think about if I want to enter the 3 number here. I think about if I enter the 3 number for this one. 3 number here. Now I want to store it into the 3 element. Right? I want to store it in the 3 element because I have 3 number. So the process here, I initialize all of them number 0. I initialize all of them number 0. Right? So now see, for index in the range of numbers, that means starting from 0, 1, and 2 here. Right? So for each of them, I got the user from user from. Sorry, I get the number from user. So if he enters the number 70, it means stored in 70 here. Right? And if you store it number 80, it's stored in the second one here. And if you store it number 90, it's stored in this one here. Make sense? Okay, that's the process in the case you work with the specific number of elements. You know for sure you do it for 3 times. You know for sure you do it for 10 times, whatever. Right? Make sense or not? Okay. Now, that is the case you want to load into the definite number of elements. You know for sure you have the 10 students in the class. You know for sure you have the 3 number in the element here, in the array here, right? But in the case, if you work with the array with the indefinite number of elements, I think about process you keep enter the name until he enters the quit. Right? That is indefinite number of the element here. So in that case, you work with the loop here. You work the while loop in the Python. You work the while loop in the Python, right? So basically for this one, you know, it work with the router also very simple, right? You see, you enter create a first student, right? And it keep enter until he enters the negative 1. Right? He keep doing it until the user enters negative 1. So see the process here. From you have to initialize the variable who controls the loop. Initialize the variable who controls the loop here. Now check the condition. Now have the action to increase the counter here. Now see, I store it into the grid here. Sorry, in the array here. Make sense? This one, right? Very straightforward here. Now, in the case you work with the Python, in the case you work with the Python here, how we work? In the case you work with the Python for the loop here. So normally for the Python, in the case you work with indefinite loop here, sorry, indefinite number of the element, you work with the append here. Append, that means add it up. Right? You do not know for sure how many elements at the beginning. That's why at the beginning you just maintain the empty here. Huh? You just initialize the empty. Now think about he entered number 10, store number 10. If he enters the number 20, store number 20. If he enters the number 30, store number 30. And the append here. Append is the action user. Add it to the list, add it to the list, add it. Make sense? Okay, that's the way you work with the Python here. In the case you work with the indefinite number of the element. Okay, so I hope that you have to understand the concept when you work with the definite number of elements and when you work with the indefinite number of elements. They are not the same when you work with the Python, or they are not the same when you work with the router. But again, one very important thing you have to remember. If you work with the real programming language, the first index always starting from 0. But if you work with the router, the first index is number 1. Huh? Any question? No? Okay. Now, some application of the array, they're very simple. The first one is sum it up together. Just sum it up. So basically, it works exactly the same when you work the loop here. So in order to sum it up, you have to maintain the accumulator. So every time you just take it out, what is a grade for every student, right? You just sum it to the accumulator. That's all. That program here. See, use the program here. Use that initialize the accumulator, right? Now we see. So it's not complete program. I'll show you later by the array, by the router here. But see, you have check the condition here. You store it into the array element, and you sum it up to the accumulator, and you have action to move to the next one, right? Okay. So whenever you want to find the sum and average, again, very important that you have to initialize an accumulator and set it to the 0 before the loop. That always follows the same rule, right? Run the loop starting from the first element to the last element for each iteration. Add the value to the current element into the accumulator. That's all. You see, when you work with the Python here, follow the same rule, right? Initialize the accumulator. Right? Now, sum or the counter in the range of the student here. Right? You get the grade of the every student, right? And you sum it up here. That's all. That's the process here. So I believe that I will upload the slide, all of the slide into the announcement. And if you want to go over, you can check it later. Right? Okay, so you see that's the process here, right? You have entered the number of students here. I maintain the counter, you maintain the accumulator here. Check the condition. So for every iteration, get the name. Sorry, get the grade of student, right? Stored into the element here, and sum it up to the accumulator. And that's all. That's the process here. So think about I run it for the 3 students again, right? And the grade for the first one, 60. You see, now the sum is 60, right? I enter the 70. Now accumulator, sum it up, you have 130 here, right? So if you have 80 here, sum it up, I have the 210 here, right? And see, I stored into the 3 element here. Grade number 1, 60, grade number 2, 70, and grade number 3 is 80 here. And now I'm able to go back to see what the grade of the number 1, grade of number 2, grade number 3, right? Because they stored separately into the different memory slot. Make sense? Any question? Come on, any question? Is this clear or not? Tell me it's clear or not. So I expect you have to actively engage in this class here, because in the next week we have the final project. You have to work the router and work with the array here. Okay, no question, right? That's okay. That's very straightforward for this one. Okay, so that is the first application when you work with the array, find the sum and average. It's very simple here, right? Now the second one, find the minimum and maximum. So now we look on the think about if I have array here, I have number 2, 4, and so on here. Now if you look on this one, what is the minimum? What's the maximum? What can you tell me? What is it? What is the minimum or what is the maximum?
Minimum would be 12, max would be 32.
Minimum is -12, right? Minimum is -12. And the maximum is 32. Right? Okay, that's correct. But tell me, how can you find it? What is the process to find? Yes, actually, yeah. That's the process here. You keep every number together, right? One by one, one by one, one by one. Basically, the same with the computer. So basically, in order to think about this one here, it's very simple. You look, it's only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's very simple, right? But what happens if you have the array of 1,000 or more than that? You cannot manually do find out, right? So you need a computer to do that. And the process, it works exactly the same with you. They compare every single one together. Right? So how we do it here? So basically for this one, how we do it here? No, for this one here. You have to assign the minimum and maximum to the value of the first element. Always follow the same rule, right? So think about this one here. Now, if I want to find out what minimum, I assign the minimum to the number 2. It's the first element. Now, I run the loop. I check for the second one. 2 less than 4, correct? I keep the same. I check for the third one. 2 greater than negative 12. So this cannot be minimum. I change it to the negative 12 here. Right? So now negative 12, I check it. Less than, correct? 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 I keep it the same. At the end of the process, it's a negative 12. Right? And again, for maximum, I do the same. I have number 2 here. Now I compare it. Number 2, less than 4. No way it can be the maximum, right? So I change it to number 4 here. Now, number 4 greater than is correct. I keep the same. Less than, I change it to the 5 here. Less than, I change it to the 8 here. Less than, I change it to 32 here. Greater than, I keep the same. 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 So it's the end of the process. I have 32. So that is the process. You work with how to find out minimum and maximum. Normally, you assign the value of the first element, and you run the loop. You check the condition here. Right? You check the condition here. So now, what do you think? Can you write the wrapper program for this one? Can you write the wrapper program to find out the value for this one? Good. What do you think? Now, see. You assign the minimum and maximum value of the first element, right? You run the loop to scan from the second element to the last element here. Now, for each iteration, you do the comparison. Now, if the minimum greater than, have no way to do it to be the minimum, right? So you update it to the new one here. And the same with the maximum. If maximum less than, it cannot be the maximum. You update it to the new number here. That's all, right? So at the end of the process, you got the what is the maximum and what's the minimum. Yes.
So in the Python code on lines 3 and 4, what is the 0? Like, what's the 0 referencing exactly? What's it?
Okay. 0, what is it? 0, that means assign the minimum maximum to the first element. 0 here. 0 here is the first element. 0 here is the first element. And both of them at the beginning, you have the number 2.
So yeah, okay, so it starts at 0 and then goes.
0 is the element. It's the position.
Right.
The element in the array, right? 0 because in the Python, the first element is starting from 0. That's why I assign the minimum and the maximum here 0. Makes sense? And now see, I do exactly the same process here. I assign here. I assign here. Now I run the loop starting from the second one. That's why number 1 here. Number 1, that means the second element. Yes.
What about the len?
Which one?
What line?
Okay. That is a function in the Python. The len function here return you how many elements you have in the array. Now think about this one. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So basically, you can replace this one here with the 10 here. The same. The 10. Right? So basically for this one here, you run everything from the number 2 to come all over to the number 9. That's subscript number 9. Make sense? Okay. So now that is the second one. Now the third one, for each iteration here, you compare here. If minimum greater than here, if minimum greater than, it can be the minimum. You update the new minimum here, right? And the maximum less than, it can be maximum. You update the maximum. And you see, at the end of the process, you find out what is the minimum and what's the maximum. Make sense? And you can do the same with the router also. You can do the same with the router. It takes quite a lot of time. So now, The third application is that you can use array to replace the negative decision. Now think about this one. You are working in the HR department, right? You need to make a report, and you see you have to list all the employees who have the claim 0 to 5 dependent. So think about what's your name? Right? My name is. Think about what's your name, right? You can record your name. My name is Hieu Tran here. How many dependents you have? I have 2, right? So now what is your name? The name is A. How many dependents? I have 2. So I increase it. You have 2 employees with the 2 dependents. Right? And make the same. Right? So see the process here. You have to do statistics, and you have to find out. You have the 43 employees with no dependent. Right? You have the 35 employees with 1 dependent. You have 24 employees with the 2 dependent, and so on. Right? Okay. So how can you do it? How can you do it here? So we can think about it very simple, right? And application here produce a count for dependent category, right? So at the end of the process, you can tell how many dependent, how many employees with the 0 and 1, 2, 3, 4, 5 dependent. Suppose that you only have everything from 0 to 5 only, right? Now, if you can think about the first thing you can think about in your mind, it's very simple. You can maintain a 6 dependent count accumulator, right? You see at the beginning here, you have the count number 0. You set it 1, count number 1, 0, count number 2, 0, count number 3, 0, count number 4, 0, and count number 5, 0. Now, see, how many dependent you have? So if I answer that I have 2, increase by 1. Now, how many dependent you have? You answer the number 4, you increase by 1. And again, how many dependent you have? For the other one, he said that you have number 2, you increase by number 2 here, and so on. They are accumulated here. Make sense? Make sense or not? Right? You want to find out the total, you want to find out the sum, you have to maintain the accumulator. For sure. So now see, you can think that one is the program here, quite simple here. Now see, you do it here. You do exactly the same with the program here, right? You do the declaration here. You have the number count number 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0. Now you check, right? Now raise the question. Raise the question here. Right? See, for each employee, raise the question. How many employees you have? Now check. If you have no employee, increase the counter 0. If not, check if 1 or not, increase the counter 1. If not, check, increase the number 2, increase the number 3, increase the number 4, and increase the number 5 here. And you do the same. That is a flowchart, and this is a pseudocode here. They work follow the same. Make sense? Make sense or not? Okay. So now see, you check it here. Now, what do you think about this program? What do you think about this program? What is it? How can you optimize? How can you make it better? Now see, the first thing you see here, the problem is the program here. You have the multiple separate input. Now think about this one. You have to maintain for the count number 0, count number 1, count number 2, count number 3, count number 4, and count number 5. And what happens if someone with the 6 dependent, 7 dependent, you have to maintain them separately. Right? The first thing, you have the netted decision. It looks very, very cumbersome. Now think about this one. It's not scale up, more dependent. So see what happened. Now, what happened if I have employee with a 7 dependent? What do you think? If I have employee with a 7 dependent, so what program? How program will work here? What do you think? 7 dependent. How's the program working?
You would just add it to the count 5.
Yes, actually, it's just added to the count 5. So see, not 0, not 1, not 2, not 3, not 4. So just add it to number 5. That's correct. It's not. So the output is not correct. In that case, you have the employee with the 6 dependent, 7 dependent, and so on. Now, again, if you want to print it out, how many employee with the 0 dependent, 1 dependent, and 2 dependent, and so on, you have to multiple separate output here. Now see, in the case you want to print it out here, right? In the case you want to print it out, you have to print it out the first, the second, the third, and so on. Now, if you have the 6, 7, and 8, right? You see, if you work with 7 and 8 with the negative decision, you have to expand it here, right? Sorry. See, again, you have to extend the selection here. Check it equal to 6 or not, 7 or not, 8 or not, or 9 or not. You have huge problem with this program. So I want to make it a better way. The first thing I can observe it here. I see. The first thing I can see is I can observe it here. The first thing is very simple here. You can see they seem quite similar together. You see, I have cow, then a cow. Same. The only difference here 0, 1, 2, 3. Okay, so I think for sure I can use the array. I can use the array. They have the same array name. The only difference here is the subscript only. So now I can do it better way. So see, I do the number cow here. That is the array. It's a 6 element. First, second, third, fourth, and fifth, and sixth. All of them 0 at the beginning. They are accumulator. That's why they have 0 beginning here. Now, so we see. I check. I do the same here. I do the same process here. If number dependent 0, I increase the cow 0 by 1. Number independent 1, I increase the cow 1 by 1, and so on here. Now, if you look on this program, I can see I have the improvement in the input here. You see, better with the declaration. So see, before I have to do it for the 1, 2, 3, 4, 5, 6 element. Now I just do for one time with the array. That's the first improvement. The second one here, better with the output. You think about this one here. If I want to print it out, I just need to do the loop. Do the loop, or in the range of 6, I print it out here. One time over. Instead of separate here. So I have the 2 improvement already, but still you have the huge problem. If you have this 6 dependent, 7 dependent, and 8 dependent, they cannot do this one. So see, they have a problem here. Net addition, it looks very cumbersome, and it's not scale up or more dependent. Okay. Now the final solution is that is that's what you see. Now you can observe it here. You can say observe it here. If I have 0 dependent, number 0, I increase the 0. If I have number 1, I increase the number 1, 2 increase the number 2, and 3 number 3, and 4 number 4, and 5 number 5. You see, they're always matching together. So why don't I replace all of the process? Why don't I replace all of the process with the simple one here? I see, I replace the simple one here. It doesn't matter what is dependent. I just increase in the counter dependent. I see. If you answer question is that you have 0 dependent, I increase the 0 here. If you answer the 1 dependent, I increase the counter 1 here. See, I can replace the whole process of the net decision by the only single command. It's very useful in this study. Make sense? Now I can show you. How to work with this one here. Now I can show you how to work with this one. Here it's a net decision here. This one. So we see it looks very cumbersome. Dependent 0, dependent 0, dependent 1, dependent 2, dependent 3, dependent 4. I see. Look very cumbersome in the case of the net decision here. And the same in the case of the Python itself. You see. So you have to maintain this 6 separate here. I have a lot of the if and else, right? And the output also. So now when I go back to my improvement here, now we can see for this one. You see that's a huge improvement when I work the adapter here. Right? So see, it doesn't matter how many dependent we have, right? How many dependent we have? You just add it up to the counter. Make sense? Let me know if it makes sense or not. Now see what happened here. What happened here? Yes. No. That makes sense, right? Because the thing is that in the case of the router, you have to starting from number 1, index number 1. Right? That's why I have to increase the depth number 1 plus 1. Make sense? The only difference here. The reason I have to increase the number 1 here and increase the subscript number 1 here because interrupter starting from the number 1. In the real programming language is starting number 0, right? So if you answer that the number dependent 0, actually I have stored in the count number 1 here, interrupter. I have no way to store it in the count number 0, right? That's why the number dependent here, I have to add to the number 1. Make sense? Okay. Now let me show you some other thing you can understand. Now, if you look on this one, you have to maintain array, right? You have the 6 element. And what is this? What is the first element here? That is index number 0. That is index number 1. And you come all over to the index number 5. That is the Python. But interrupter, you cannot starting from the number 1. That's why you can starting from the number 0. You have starting the first element is number 5 and the last element is number 6. That's the only reason here. You see, the index interrupter always greater than the index in the Python 1. 1 that means 0. 6 that means 5 here. Make sense or not? Now you make sense for this one. You got it or not? For this one. Now that's why the reason here. When I work with interrupter, for that reason here, when I work with interrupter, that's the only reason here. I add to number 1 here. You see, if what happened if he answer question here, how many dependent you have, right? So what happened here? The question how many dependent, I answer the number 0. So I expect in my program that I will increase the count number 1 by 1 because I have no count number 0 interrupter. Make sense or not? Yeah, that's all. It's always add the number 1 here. Just add number 1 here because it's always greater than 1. If you have the element 0 in the Python, actually it's element 1 in interrupter. And if you have element 1 in the Python, you have element 2 interrupter. That's why I add in number 1 here. Make sense? And of course, it depends on the question. It depends on the answer. If you answer that I have the 2 dependent, you have the 2 dependent, you have stored into the count tree interrupter. So basically, you see, an interrupter, you have the count. You have the count number 1, count number 2, count number 3, count number 4, count number 5, number 6, all of them 0 at the beginning. I see. How many dependent you have? I have 0 dependent. I have to increase this one by 1. That's why I have the department 0. Not 1. Make sense?
Could you enter 9 on this program?
What a 9?
Like dependents, enter 9.
Let me show you. That's a very good question. It worked well. It doesn't matter. It doesn't matter.
Why does the assignment say count 6 at the top?
Count 6 actually is that I want to show you that in some case you have initialized, but in interrupter you do not need. Actually, in interrupter you do not need. You don't need it here. Okay, I think you have to do that because you have to set it to 0 at the beginning. You have to do that. So now think about this one. You can interrupter. You cannot. I can add it. So the number 10. Okay. So we think about this one here. I do not want to modify anyone. I show you later. So we think about this one. Now enter the number dependent. I have 0. What happened here? I see increase here by 1. Now how many dependent? 0 again. Increase it by 2 here. How many dependent? 0 again. Increase it by 3. Okay. So see, if you have 0 dependent, actually it's stored in the first element. That's why I have to add 1 here. Make sense? Now what happened here? If I enter the number two dependent, actually you can store in the number 3. Right? See, number 3 here. Make sense? That's why. That's the reason. So negative 1 here. So see, at the end, I just bring it down. Yeah, right? Number belonging is a 0 dependent number 3, and one of them is a 2 dependent. It works exactly perfect. Right? Works exactly perfect. And see, if I want to print it out again, I have to minus 1 here. Huh? Okay. I added 1, that's why now I have to minus 1. That's one thing I do not like about the adapter. Why don't they start in from 0? It's quite confusing. Okay, anyway, that is the way you work with the adapter, right? Now I can show you how you work with the So for this one also, I have 0, I have 1, I have 0 again, I have 3, I have 4, I have 2, I have 5, negative 1. So I can bring it down, right? I can bring it down. So this one. Yeah, so we have number 0 here, and so on. So that is the case you work with the method decision, right? So now you see, I replace the whole process with this one only. Now you see the whole process with the method decision. Now I work with this one here. Now we can see what happened. Now I open the new one. This one, replace it. And yeah, you can compare the yes, and we see here. So see, right? In the left is the method decision. Right? In the right, I replace the whole process by just one command. Right? It's way better when you have to break it down the whole process here for this one. But for this one, I only need the one action for this one. Make sense?
What is the plus or equal one on that line?
Sorry, say again.
Or is this not dependent? The one that you're on.
This one?
Line 5.
Okay, so actually in the Python, it is a shortcut of this process. Shortcut of this process. That's all. Actually, it increases by 1.
Oh.
That's the process. Yeah, that's the process in Python. It's a very good question. Good observation. Okay. Yeah, another question is very good here. Why do you have to put the 15? I just to make sure that in case I have the employee with the 15 dependent here. It works well with this one, right? It works well with this one here. Now think about it. This one here. I run this program. Now I think about it. I have to change. Alright, so I think about I run this program. Number dependent. I have 14 here, right? I have 15 here. Sorry, I cannot 15. This one. So I think 14 only. So I have 14. So 14. 12 here. 11 here. 10 here. 6 here. 3 here. You see, it works well, right? It works well. That doesn't matter that you have the 6 or 7 or 15 dependent here. But for this program, you see what happened here. If you have the 6 or 7 or 8 dependent, always increase the car file. Right? It's not correct. Right? So basically, if you want to break it down further, you have to else, if more. Right? Makes sense. So you see the whole process of the method decision here. You can replace it with only single command in the case of the array here. Right? Make sense? Make sense or not? Now see, you can see what is a huge difference here. I have to create the 6 separate element here. Right? Now I just do it by one single array. That's the first thing, right? The second thing here, the whole process of the if and else here, I just replace by this command only. Right? And you see, in order to print it out output here, I have to do it very manually for all of them. Right? Now I just need to do the loop here, do it one time only. A huge improvement when I work with the method decision. I replace method decision with the loop, with the array. Make sense? Okay. Any other question? Let me know. Any question? Okay. So see this problem here. So no more cumbersome method decision. So even that you have to break it down 6, 7, 8, or 9, or 10. It doesn't matter. You just replace all of them with a single command here. Right? And scale up well to more dependent. So I show you that even I have the 14 dependent work well. Right? It doesn't matter. Okay. Now we move to the number 4 application. Is searching for an array in the exact match here. Now the thing about this program, it works very simple program. Very simple. Now think about you have you are working in the grocery store, right? You have the grocery store, and in that you have the code for all of the items. I think about cabbage or apple, whatever. All of them, they have the unique code here, right? So that means it's a valid item here. So we have the code 106, 108, and 307, and so on here. And that is very simple. We have 1, 2, 3, 4, 5, 6. But you can think about in the case you work in the grocery, you have 1,000 of them, right? So we can store them. You can store all of the code in the array here. You can store all of the code in the array, right? So now what happened here? You have the customer, you want to buy something, right? So enter the number of item. Okay, what is it? I can think about. Okay, I think should be better that if you enter the item, I'll say item number or enter the code here. Right? What's the code of the item you want to buy? So see, when he enters the code, you have to make sure that you have to check if the code here in the valid item or not. Right? So if it's in the valid item, you what is it? If the valid item, you print it out, right? Item available. If not, you print it out. Item is not valid number here. Make sense? Okay. Now, what do you think? How can you find it? How can you write program to find it? So whenever you got the number from user, how can you find it? How can you write the program to find it? What's the algorithm here? Now think about what happened here. What happened if I enter the number 70? Now think about it, very simple. We have 1, 2, 3, 4, 5, 6 here, right? Now, ask the question. User here, enter the item number 70. So how can you find and tell that the 70 is not in the valid item? How?
We go through check that it's not.
Yeah, you do the loop, right? You do the loop, you compare every single element in the loop. As compare, not the same. Move to the second one. Compare, not the same, not the same, not the same, not the same, not the same. End of the process. And at the end, you see, item is invalid number. Huh? Make sense? And what happened here? If I enter the number 108, you see, not, but 108 here, correct, and print it out. Item is available. Okay? Can you write program interrupter? Do it. I'm too tired. I want to take a break. And you do it interrupter here. And I can correct your work. Now do this one interrupter. You can see it's a process here, right? So in order to do that here, the process here, At the beginning, you set the flag, it's private and no. You suppose that at the beginning you have no private yet, right? So whenever you sum here, you have the sub is 0 here. That means you're starting from the first element. You run all the way to the last element. So every time you check it, right? If the item is a valid item, you change the flag from no to yes. Right? You change the from no to yes here. Okay, do it in the router. Do it in the router. You open the slide. So I believe that I will upload slide in the announcement already. And if you want, you can look it up in the announcement. Yeah, slide for module 6 here. You can download it from here. Now do it. Do this program. Huh? Okay. Enter the number here. Right? So basically, in the router here. In the router, you cannot do by the way you put in the 0 here, but actually you have to declare separately. You have valid item number 1, you put 106, and you move on. Like valid item number 2, you have 108, and so on. Right? Yeah, let me show you how to initialize it. So basically here is a router. If you want to define for every element in the array, you have to do it separately here. Valid number 1, 106, valid number 2, 108, valid number 3, and so on. Okay. Now do this program with router here. And if you need any help from me, just let me know. Yeah, and so on. You have the valid number 3. Just copy it. Just copy it and paste it. The first item is 688, right? What's the second one?
6 item is 688.
Sorry, the first one
106.
Okay. 106, 108, and
307.
307,
305.
405,
457.
457,
688.
688. Yeah. Now see. What is the number, right? You enter here, think about here, and there's a number 70 here, right? So at the beginning, power with no. Set it, right? At the beginning, I have not power with yet. Right? I starting from the sub 0. That means I starting from this one. Right? So now I check if the sub here left hand side is the 6, right? Side is the 6. 1, 2, 3, 4, 5, 6, right? So see, sub now 0, left hand 6, correct? Right? I do it, check. If the item 70 here equal to the sub here at the beginning is 0, right? It equal to 106 or not? No. I move to the second item. Make sense? I move to the second item. I go back. Now the sub now is number 1. 1 stay less than 6, right? Correct? Again, item now equal to the sub now number 1, right? That's why equal to 108 or not? No. Move on. Move to the second one. Sub 1. Do it all the way to the last item. And you see, in the last item here, I have not found it yet, right? So all of them, as you see, stay the same as no here. So I check if no here, that means here. You have no, I increase the bad item by 1. That's all. Make sense? Now what happened here? Now that is the case you are not able to find. Now what happened if he entered 108 here? If he entered 108 here, you can see what happened. If 108 starting from the first element. Not correct, right? Move to the second one. 108 here, check, correct. You change the flag to the yes. Change the flag to yes. So now the flag to yes at the end of the process, yes, print it out. You find it here. Make sense? That's all. Now, is it make sense or not? Yeah, you can do the same. You can do the same with this one. Okay, now can you see me? Now if you look on the program, right? I have initialized here the size 6, right? Of all the item here. All the item here. At the beginning, no background item yet, like 0 here, right? I have the message yes, item available. Message no, item not found. Finish 1999 here. So I do exactly the same with this one. Yeah, I do exactly the same with declaration, right? So see, I initialize all of the element in the array. I set the back item count 0, the message yes, message no, and finish 999 here. So it works exactly the same with my declaration here, initialize here. Now go back. I get that D. Get that D is that user get the item, right? And enter 999 to exit here. Very simple. So when I got to get that D, the prime input, I go to the loop. I check if the item equal to 999 or not. If no, I do the process of scanning. I do the process of scanning item here. I scan it everything from the first element to the last element. So how I do it? I starting from the first element here, right? Starting from the first element here. Now, if it go all over to the last element, that means here it go over to the last element to exit it, right? If not, for each of them here, I see I compare it. If equal or not, if equal, I change it to 0. If no, I do nothing and I increase to the next item here, right? And move it, do it the whole process to the last one here. And ends the process, you have the two ways. You have two options here, right? In the case you found it, you print it out found it. In the case you know, you print it out no, and you increase the byte item by 1. That's all. Right? So now I can show you how we done it here. Now how I done it here. I think it should be better. I run it step by step here. Now think about initialize here. Initialize already. Now get ready. Enter the item. The 70 here is not correct one, right? 70 here is not correct one. Oh, this one we have to do in the modular structure. I believe I show it in the class for more than one time already. It's modular structure, right? And if you want, you can watch again the recording video how to do it. Or I believe that I have the recording video. Let me show you. I think I saw it in the YouTube. I have many videos. I don't know. Let me see it again. So let me show it again. Yeah, this one. show you how to work with the anyway, let me show you here again. Let me show you again, right? So think about if you want to find out the area of the rectangle, right? So you have you need to input from the user for the length and the width. So we can break it down into 3 modular structure here. Think about I need to print it out. The first one here, I use the code here, right? And I print it out here. Input data. Okay, so you see, we have input data here, right? So in the input data here, user need to input from that. You have to enter the length. Put the length here. And I put. Sorry. Why you raise it question at that time? This time. I explained it already in the class. Okay, so see, I already have the generator modular input, right? So now I need to want to do one more thing with the thing about the calculation. I put it here. So in the calculation, I have area. I have assignment area. Its length and width. And I have one more about the output here, that data. In that case, I just print it out, right? I just print it out. Okay, so now see, if you look on my main program here, I break it down in 3 modular structure, right? I got the input data, I got the calculation, I got the data output. So see, when you see execute program, it runs from in the sequence here. What's the input data? Jump to the modular input data, right? Get the length, get the width, and return it to the main module. Move to the calculation. What's the calculation? You figure out what's the area, right? You go back to the main module, and the data output, so print it out here. So when you run it here, you have the 20, and you have 10 now, and you print it out. Why I have to get it? Input, calculation, data output. Yeah, right? So see, make sense? And you know how to work with the modular structure? Welcome. Okay. So now I go back to my program. I see. I initiate it now. Let me run it one step by step here, right? Let me run step by step here. I can show you how to work with the program. So now run it step by step. Now, what happened here? If I enter the 70, right? So the process here, it runs everything from the first element. Now see, look here, 5 item here. What's the 5 item? It's set no at the beginning, right? Run from the first element here. See, run from the first element. Check if not if greater than size, that means 6 element, right? Not yes. Do it. So we see if 70 equal to the valid item sub here. What is sub? Sub now number 1, right? Sub now number 1, that means it's not equal to 106, right? not equal to order 6, what happened? Move to the next one. Move to the next one. Again, check if equal to 108 or not. No. Move to the next one. See, at the end of the process, you are not able to find it. Right? At the end of the process, you are not able to find it. That's why you print it out here. Right? And you increase the one item by 1. Now I want to exit it here. Right? I put it 999. So that's my output here. Item not found. Right? Make sense? That's process here. When you got the item, scan it from the first element to the last element. For each iteration, you compare them. It's a comparative, right? And the only difference between the iteration, you see, the only difference between the iteration is the where? Here. The only difference here, the sum. The sum is an element number, right? Number 1, number 2, number 3, number 4, and go all the end to the last element. Make sense? Okay. Now see what happened here. What happened if I enter it correctly with the one? This thing about 108 here. Right? Let me stop it again. 108 here. 108. You see at the beginning, right? You see at the beginning here. What happened here? Back item, right? Now look. High item here. Now see. Found it at the beginning, no, right? But whenever I match it here, now the first item not match, move to the second item. Second item here, 108 match, right? Move to this one. I change the found it to yet here. I see, change to yet here. Right? So at the end of the process, I found it and print that item is available. Make sense? Yeah. Okay. Now, what do you think about this program? My question. Do you think if you can think it make better with the program? Yes. What is it?
I would say because it runs through it for every single one. So if it's right on the first one, it'll keep going.
Yes, right? Yes. So that's the thing here. So what happens if you have 100 or 1,000 items? So even that you find for the first element, you still have to do it or multiple times. So how can you make improve? How can you and how can they overcome that problem?
Set the sum to 0.
Sorry?
The element to 0 and then have it as a counter up to.
Yes, that's the way to work. That's the way to do it. You have many ways to do that. You have many ways to do that. You can set the right side to 0. It's okay. Right? It's okay. But I think that's one here. You can have another way. You can set. You see when you have the power with yes, you should immediately exit. So instead of using the sub greater than sign, or you can check one more condition or condition, right? Or the power is equal to yes, exit it. Right? So see, I can correct it here. Right? I can correct it by program here. Some program is so work. You change it to 0, it's okay. It's okay. But yeah, now see, you can change it off here. All right, or file it here. And change it to equal to unity. Okay, so now see what happened here. If I run it, right? If I run it here. Now I put it 106. Immediately exit. Okay. Yeah, right? Exit it. See, only do it one time. You do not have to scan for all of the remaining items. Make sense? Okay. So I think that's all for today. This chapter is very, very long. And anyway, it's very, very interesting if you really interested on that. So again, my suggestion, right? Go back, go home. You can read that as a slide if you want, or you can watch a recording video if you want, and come back to me with the homework assignment and with the debugging exercise, with the raptor assignment, and any other assignment you might have on Thursday. Okay? Let me check the attendance again. And I still believe that if you really actively engage in the class, it's okay. I can see that all of you here, you engage in this class. You You have very great, good rating because you understand the problem. John, are you here? Jalen, are you here?
Yeah.
Content, are you here? Content. Eric, are you here?
Yeah.
Joe, are you here? Evan, are you here? And Lindsay. Lindsay, are you here? Michael. Michael, are you here? Matt, I'm here. Mary. Bill, are you here? Hunter, here.
Yeah.
Tyrick, are you here? Tyrick. Okay. Max, are you here? John.
Here.
Paul.
Sorry, I meant here for Paul, not John.
Daniel, are you here? Daniel. Parker. Carl. Parker here. Carl, are you here? Alex, are you here?
Here.
Here. Tucker, are you here? Tucker. Look here. Marcom here. Okay. So again, I see you on Thursday, and again my short session. Go back to watch over it again and get ready with your homework assignment. And if you need any help from me, just let me know on Thursday. Okay. Bye, you guys. Bye bye.